Hello my fellow CAD lovers, and welcome to the fourth part of this tutorial on creating a spiral casing in Autodesk Inventor. We have finally reached the point where we can leave the master part and proceed to the creation of the components that will make up our final assembly. But before we jump to that, we are going to make some change that will ease our life down the road. The first thing we want to change is the thickness. Since all the components in our assembly will have 12 millimeters as thickness, it is a good idea to drive them from a single location. And we will do that by accessing this sheet metal defaults in the sheet metal tab. So we will click on sheet metal defaults, and what we will do is to untick this use thickness from rule option, and we will input 12 millimeters as the thickness, and then OK. Next we will move to this manage tab, and we will select parameters, and what we are going to do here is to make sure that all the 15-degree angles are linked to this expression. To do so, we are going to copy this, right click copy, and paste the value like this. So paste. So this is one way of doing this. The second way is to select the input and then move to this arrow and click on it, then select list parameter, and then you can select the parameter from there. I'm going to use the paste method, seems to be faster. So again, paste, paste, and paste, and paste, paste, and paste. So, and this one also, I am not sure, so we'll see. So paste, that one, paste, and then done. For sketch 17 and sketch 18, so we don't want the 15-degree angles, we will use something smaller instead. So we will move to this sketch and edit the value. We double click on it, and we will use 0.5 degree, so we want something smaller, and finish the sketch. We do the same for this one. We use 0.5, and there we go. Now, to create components from the master part, we are going to use the make part tool. The make part tool will allow us to copy sketches and parameters from the master part, drop them into a new part, and from there we will add the necessary geometry to make the components. The make part tool is available in this manage tab, but we can also find it from this sheet metal tab and flat pattern panel. So make part tool. In the make part dialog, we have a set of options. The first group of options is the Derive Style. So we have single solid body, you have solid body keep seam between planar face, or this doesn't matter anyway. So make sure that we have this maintain each solid as a solid body option active. Then we have the status. So this one will mean that the object is active for the derive operation, and this one will make sure that the object is excluded. And here we have a picture tree, and this basically shows us all the objects that are inside the master part. So we can have solid bodies, surface bodies, blocks, sketches, and so on. And when they are featured inside a folder, we have this plus sign. So if you click on the plus sign, you can expand it and access to those objects. So we are going to use sketches and parameters, and for the first part we are going to use the sketch 01 and sketch 02. So we will expand this sketches folder, and we will click on this icon to activate the sketch for the derive operation. We will do the same for sketch 02, and next we are going to expand the parameters, then sheet metal parameters, not not sheet metal parameters, but instead model parameters, and we will use the thickness one. Okay, so on the right side of the dialog we have part name. So we want to create the sheet metal component from sketch 01 to sketch 02. So we will name the part 01, 02, so that we will always easily know that this part was created from the two first sketches. Next, for the template, we are going to use a metric template. So metric, and then we will select sheet metal millimeters.ipt. Then OK. Now the new file location, so we have our working directory, which is good. Next, we have this option, place in target assembly, which must be active, and then we will enter a name for our target assembly. So we will use spiral casing. Okay, and for the assembly we also need to select a template. We are going to select a metric template and standard millimeter.iam, then OK, and everything is pretty much set up. So we will click on OK, and as you can see we have a new tab open and the screen layout is changed. We are in the assembly environment, and as you can see in the model tree we have the spiral casing assembly, and in the assembly we have this first component 01 to 02. Okay, to see the sketches in this part we are going to select this zoom all button, and you can see that we have two sketches inside the component. Now to edit the component and create the geometry, we can double click on the component, and as you can see we are back into the sheet metal environment, and we have at the end of the sheet metal tab this button, return to the assembly, return to parent or return to top. So this button will allow us to return to the top level assembly. Okay, now we can create the geometry, and to do so we are going to use this Lofted Flange tool. So we select Lofted Flange. The first profile will be this arc, and the second profile this second one. And as you can see we have some geometry on the screen, but it is not looking as we expected. I was expecting something smoother, and this is because we have this option press break selected by default. We are going to change it for this die form option, which is more consistent with the manufacturing process of this kind of component. And now we make sure that the material is added on the correct side, which is the exterior, and then OK. There we go, we have our first sheet metal components. And before we proceed we are going to make some change in the view. So we will change to visual style, and we make sure that we have shaded with edge. Okay, so to finish this component we need to make some room for the two rings onto which all the sheet components are fitted and welded, and we will do so by creating a circular opening with a diameter of 815 millimeters. So we are going to go back to our master part, and we will add, as we did plenty of time before, a sketch on the XY plane, and we select our cycle tool, then 815 as the diameter, and we are going to finish the sketch. And before we move to the next step we will rename this as ring underscore opening. Okay, now we will save the master part, then go back to the assembly, and to add the newly created sketch onto this component, what we can do is to expand this folded model group, then access this master part.ipt feature and use this edit derive part, or right click and select edit derive part. we will go back to this Derive part dialog, and from there we can expand the sketches group and add this ring opening to the selection. As you can see, now we have these 2 sketches and this third additional one. So we will click OK, and as you can see, the sketch is added to the component, and now we can perform the cut. Okay, so to create the cut, we are going to use this cut tool from the sheet metal tab. So cut, and the sketch is automatically selected as the profile. Now for the extent, we are going to keep the distance option, and we will input a value something like 650, and we are going to make sure that the cut is performed symmetrically, something like this. Then OK, and that is for this component. So we can create a flat pattern. So create a flat pattern, then zoom all. As you can see, we have a flat pattern which is usable for the manufacturing process. Okay, so now let's go back to the folded part and save the component, and inside the assembly now you can see we have the first sheet metal component created. Before we proceed to the next component, there is something we must add. So let me zoom fit first. Something we must check is the thickness. So as you can see, we have the 12mm thickness, but if we move to this manage and access parameters, you can see that the thickness is not linked to the thickness parameters we derive from the master part. We need to make the link, so we select this little arrow, list parameters, and select thickness 1. Now if we change the thickness from the master part, the value will be automatically updated in this component. Okay, let's click on done to close the dialog, and we are pretty much done for this component. It was not very difficult to create, but as you notice, there is a lot of steps involved, and because we are going to have to repeat these steps a lot of time to create the remaining components, we need to make some improvement to our workflow. The first thing we will do is to restrict the number of templates available when we invoke the make part tool. So we will not have to browse through a bunch of templates to get to the one we need. The second improvement is related to the way we activate command. Until now, what we did was to move to the ribbon bar, activate the right tab, and move to the appropriate panel and select the tool. This is too much mouse travel, and it can be reduced by using the marking menu. So to access this marking menu, we just have to make a right click and select the tool we want. So first we are going to start by reducing the number of templates available, and to do so we have to make sure that we save all our files. So we save the master part, the assembly, and the first component. So we are going to have to close them first so that we can go back to the project file and make sure that spiral casing is the active project. Then move to this folder option, and you will have this template folder. So select it, right click, and choose edit. Now we will have this path which defines the location of the templates. So what we are going to do next is to do a right click and copy the path, then move to Window Explorer and paste the path and press enter. Now you are in the directory where all the Inventor templates are stored. So you have this English, metric, mold design, and so on. So we are going to enter the metric templates by double clicking, and what we want is to select the standard millimeter, then the sheet metal template, and okay, so we'll just have these two selected. Then we will right click and copy them, and now we will go back to our working directory and create a folder name templates, inside which we are going to paste these two templates. So next we go back to the project file, and we are going to change this to the location we defined. So edit, then we will use this button browse, and we will browse to the template folder inside our working directory. So this one, and then OK, and to finish, save and done. Now we open our master part. So the master part first, then our spiral casing assembly, open. From the master part we will activate the make part tool, and as you can see now we only have the sheet metal template and the standard millimeter part template. Okay, so this is good. For now we are going to cancel because we are going to make some change to the marking menu. So first, the marking menu is accessed by right clicking on the graphic area, and you have this set of tools and the regular right click menu. Okay, so this menu is context sensitive. So for example, if you select a sketch and then right click, you can see that the behavior is different from what you get when you click in the graphic area. Okay, so since we have a limited set of tools we are going to use regularly, it's a good idea to customize this marking menu so that we have all we need at hand. Okay, so to customize the marking menu, what we have to do is to right click on the ribbon and select customize user commands. Then we have in the customize dialog box the ribbon that can be customized, the keyboard, the marking menu. Okay, so the content of the marking menu is dependent on the environment and the selection. So for the environment, we are going to make sure that we have sheet metal selected, since we are in a sheet metal part. And for the sub environment, we are going to first have none selected, as we can also have 2D sketch objects. So this will define how the marking menu looks when a sketch is selected. And we have some other option we are not going to use for this tutorial, so we are going to keep none selected. And what we want to have is, instead of this measure tool, to have the Lofted Flange tool. So we are going to search the Lofted Flange command, so Lofted, and select it. As you can see, the measure tool is replaced by the Lofted Flange. Next, we want the cut tool, so the cut tool is here, and we want also the parameters tool. So we are going to select this undo, and we are going to look for parameters, and it is this one. So we have what we need for now. We could change that later if you want. If you made a mistake and you want to go back to the original state of the marking menu, all you have to do is to click on this restore button. For now, we are done with the marking menu for the sheet metal environment, so we are going to click OK. And from now, when we will right click, we will have the Lofted Flange available, the parameters, the sheet metal default, and the cut and flat pattern also. So that will do the trick. And maybe we should also add the make part tool. So again, customize and marking menu, we will replace this new sketch with the make part. So this will become make part, and we are set to go for the next component. Let's go right away. So we right click, make part tool, and in the sketches folder we will select 2, 3, then the ring opening, and for the parameters we will add the thickness we defined in the master part. So the name of the part will be 0203. For the templates we will select sheet metal, and we do not have to change any of these since they are already properly defined. Then OK, and now we have the second component in place. And from here what we want to do is to double click on the component to enter the sheet metal environment, and then right click, access the Lofted Flange, select this first, then the second sketch as profile 1 and profile 2. Then we will change this output option to die form, and OK to finish. Next we right click to access the marking menu, then cut, and for the thickness we will select this parameter we input in the previous operation when we create the first part, excuse me, and then make the cut symmetrical, then OK. Now the last step is to link the parameters. So again, marking menu, parameters, and we will link the thickness to this one, and done. So second part is done. Then we return to the assembly. So now for the next part, make part, then 3 to 4, then this ring and the thickness. So this time 3 to 4 metal millimeter. OK, double click to edit, Lofted Flange, first profile, second profile, we change the option, then OK, then the cut, we change the thickness, and then symmetrically. OK, the parameters, so right click parameters, and we link this to that, and then OK. Now let's exit the edit and return to the top level assembly. And now I will change the view style to shaded with edge. I don't like shaded only. So next we switch to the master part again, make part, and this time for 4 to 5 ring opening. Then we make sure we add the thickness, so 4 to 5, template metal millimeter. OK, double click to edit, Lofted Flange, first profile, second profile, we change the output type. OK, then the cut, we change the extent and we make sure it's symmetrical, then OK. Finish the parameters, we make the link, and I can guess that by now you grasp all the steps involved, so I am going to shut up and speed up the video, and I will come back to you when everything will be done. If you remember the Solid Edge version, this part was a bit difficult to do, so we will see how it goes in Inventor. So I'll just select this first profile, second profile, then change the type of output, and as you can see, the result is pretty decent. I was not expecting it to go so well. I am quite impressed by Inventor capability to create this kind of geometry. So very impressed. So we also trim it, then link the thickness, and return. Looking quite nice. I am very impressed. Okay, so next one. So this and this. So like that. This will be 16 or 17, I guess. And this one maybe. Just to be sure. For the last one, we will not need the ring opening sketch. 17 and 18, then the thickness. This one, 17, 18, activate. Okay, we double click to activate, then Lofted Flange. Pretty much done for the main case. In the next part, we are going to add the deflector and the two rings where the sheet metal components are fitted and welded. So I hope to see you then, and thanks for watching.